All right, welcome to this virtual Fluid Mechanics Day. I hope you're enjoying your snow day. Just wanted to give a quick overview of what's going on in fluids so that we're all on the same page. So if you go to Moodle, you'll notice a few things changed. We have some extra stuff here for week 2. So like we're typically going to do, we have new homework assigned. So we have homework number 2, which is due in 1 week. And after today's virtual lecture, you'll be able to complete homework number 2. So if you have extra time this weekend, locked in Saturday because of the snow, that could be a good thing to start on. But what's happening today, right? No quiz. We were supposed to have a quiz today. That will not be happening. That will be happening on Monday, assuming there's no snow day. But that will be happening on Monday. It'll be a short quiz on flow visualization. So maybe just remind yourself of some of those terms. That's happening Monday. What's happening today is 2 virtual lectures. So there's this first one, which is part 1, an introduction to viscosity. You'll find down below it a note outline, which is this if you want to print this or have an ability to print this and follow along. There is also a filled out version with my extra notes and scribbles here as well. You're welcome to use either of those however you see best, as well as watch the video and follow along with that. Then part 2 of this lecture is doing an example, with Newton's law of viscosity. So that again has these an outline as well as completed notes. Once you're done with that, that should be about 30 or so minutes, 35 minutes. There is an in-class thing where you are going to be using Newton's law of viscosity to look at flow in a pipe. So this is just a good practice for using some of these things and hopefully understanding some of these terms a little bit better. You're given a velocity field. So this is the velocity field for flow in a pipe. Again, trust me on it. Eventually we'll be able to figure this out for ourselves. The maximum velocity is at the center. In question 1, you're asked, where would the shear stress be a minimum, right? So shear stress, again, you're thinking of layers of fluid kind of sliding past each other. So where is the fluid kind of traveling together instead of sliding past something else? Maybe a hint for part 1. You can also look, where is the slope of the velocity equal to a minimum? In part B, the kind of hint for that is you can calculate it without really thinking too hard once you understand what you're answering in A. Not a lot of math, just some thinking. Part 2, you need a little bit of math. So you're going to have to get your math hat on. And basically what we're going to do in part 2, we're going to determine an expression for shear stress at the pipe wall. So as we'll say in the video, this equation here, we're going to try to use it. So we're taking the R derivative of U. Up here at the top, we have an equation for U. So you're going to take the R derivative and then plug in everywhere there's a little r, you'll plug in a big R. My hint for this is you should end up with an equation that doesn't have too many variables in it. It's dependent on Umax, it's dependent on viscosity, and it's dependent on the pipe radius, R. So hopefully you can figure out what's the shear stress or the friction at the pipe wall there in number 2. So a chance to get a little bit of a sense of some of the math behind shear stress. So once you're done with that, you are set and ready to go on the homework. Again, that is due on Friday. Hopefully come to class with this either done or at least maybe some good questions on that. We'll have a few minutes in class on Monday to be able to wrap this up, but you should have tried it and thought about it. If you can't print this, feel free to work on this on a separate piece of paper. That's totally fine. All right, good luck with virtual class. Stay warm and toasty this weekend, and I'll see you back on Monday.